But too bad. Okay, focus, guys. Sorry that I didn't start out how normally class does. Okay, so let's just quickly go through this to give people that are all using the restroom a second to get back. So we have our opposite and hypotenuse. So you set up the trig ratio what? So you said sine of 60 degrees equals opposite over hypotenuse. So x will be 10 sine of 60. Now we're getting these memorized, hopefully. That's one of the special right triangles, or on the unit circle, in other words, right? So we would not give an approximate answer. We would give an exact answer. What is the sine at 60 degrees? The x value, the y value, so you said the square root of 3 over 2. Very good. When multiplying, we multiply straight across. I saw many of you get it right. 10 and 2 divide out to be 5. Perfect. You guys are great. Okay, awesome. We're going to get started. You're going to want to take some good notes today. This is one of my, I like this lesson. It's super fun. It always throws students for a loop, this one part of the lesson, so hopefully I can help make sense of it and make it easy for you, because I am a visual learner sometimes, and so I'm going to give you lots of visuals today to kind of help you see why it makes sense, not just give you the rule. Okay, so everybody focusing. So today we're going to be doing the law of sines. So we're going to be using the law of sines to solve for missing side or missing angles of non-right triangles. So far this unit, we've dealt with all right triangles. And so now we're going to get into where we're not dealing with necessarily a right triangle. A non-right triangle is what we're going to be dealing with. So after this, you're going to be able to solve any type of triangle. There is a lot of law of sines and law of cosines on your ACTs. Because they want to know, they basically say there'll be a right triangle problem because everybody should know how to solve right triangle stuff, but there will definitely be something involving a non-right triangle. So they want to know you know your pre-calculus. Okay, so non-right triangle is called an oblique triangle. So there's a no 90-degree angle here. So this is just an oblique triangle. So I have this here. This is angle A. They always state angles with capital letters, so angle A. Angle C, angle B, a side across from angle B is side B, across from angle A is side A, and across from angle C is side C. And they do the sides with little variables, okay. All right, so to solve an oblique triangle, we must have at least one side and then any other two parts. So I'll say that again. To be able to actually find missing pieces of an oblique triangle, we have to at least have one side and then any other two parts. So this is when we're going to use the law of sines. One, if we have two angles and any side. If we have two angles and any side, then we're going to be able to use the law of sines. So I just want you to look at these two triangles here. Do you see how in order, this would be reading it as angle, you have to go in the correct order, angle, side, angle, everybody. If I gave you those things, do you see how you'd be given the information in angle, side, angle? If I gave you that information, do you see what I'm saying? Okay, we could solve this one using the law of sines. Then also, do you see how this reads angle, then side? If I gave you those values, that would be angle, then side. Everybody understand? That was a secondary two thing, but once again, angle, side. Then we would be able to use the law of sines to solve for missing sides and missing angles. Well, the missing angle would be easy for this one, right? Everybody? 180 minus that, right? But then to solve for other sides, we would use the law of sines. Okay, two, we can use the law of sines. I'm going to explain what the law of sines is in just a second. So if we have two sides and one angle, as long as the angle is opposite of one of the given sides. So instead of being given two angles, if we're given one angle and two sides, we can use the law of sines as long as one of the given sides is across from the given angle. So do you see how this angle was given, across from it was a given side? And then we were given one other side, we could use the law of sines. So those are the times, 1 and 2, these are the two times we're going to use the law of sines. If we were given other information that was not one of these things, then we use the law of cosines, which we'll learn next time. Does everybody have this written down? Here is the law of sines. So given triangle ABC and these sides. This is true for the law of sines, and then I'm going to show you why this is true. So this is the law of sines. What the law of sines says is sine of angle A divided by A, the ratio of sine of the angle over the side, will be equal to sine of angle B over side B, will be equal to the ratio of sine C over side C. So these ratios will be equal. So that's also true. You could flip it. The reciprocal is also true. So we could also say A over sine of A will be equal to B over sine of B will be equal to C over sine of C. So those ratios will be true. The true statement is those ratios will be equal. They for sure will be equal. Now, and I'll show you where the law of sines comes from next. But you just have to write down the rule first. So sine of the angle divided by the side across equals sine of the angle divided by the side across. Does that make sense?
Wait, do you have to walk
Not this lesson.
like that?
Yes. You guys already learned this?
Yeah.
All right. So it'll hopefully, now your guys' brains are much more developed. It's going to make sense this time if it didn't the first time. Or else maybe this time something will click that didn't last time. Or if it already clicked, then it will just be easy. Okay. So why does this work? So we just got to get really into it here. So I'm just going to tell you. I'm not going to have you explore it. Sorry. Here we go. Let's go. We're going up we're going up this distance. And then can't we drop down a height? Yeah? Let's drop an altitude of 90 degrees. Now don't we have two different 90-degree triangles, everybody? Okay, so I'm showing to you why the law of sines works. So if we go to angle A and write the sine value, that would be sine, because it's a 90-degree triangle. So sine of A equals opposite, which is H, over hypotenuse, which is side B. Isn't that true? Okay, sweet. Let's set up another one. So let's go to this angle B. So we're going to say sine of B equals opposite, which is H, over hypotenuse, which is A. Correct, everybody? Isn't that a true statement? Okay. Now let's solve for H over here. So we're going to multiply both sides by B. So we have H is equal to B sine of A. Now we're going to solve for H. So we'll multiply both sides by A. So we have H is equal to A sine of B. Everybody good? Look, H and H. What is those H's equal? So if this H and this is H, then they're both equal to each other, right? So we would say B sine of A equals A sine of B. Now let's divide both sides by A. Now let's multiply or divide both sides by B. So what happens over here? Sine of A, oops, you guys stop, I can't focus. Sine of A over A, do you guys see it?
Yeah.
Equals sine of B over B. Okay, cool. So that is why. Okay, so that's why this works. This just makes it quicker so you don't have to have all these different triangles and go about this way. Okay, sweet. So here's my first example. I would write this down in my notes if I was you, but I'm not you, so whatever you want. Okay, so here we go. It says find all the missing parts. So I'm going to go through and label this. So we need to find angle A, we need to find side A and side C. Now notice, this is the first thing I would check. I have two angles and this is not a right triangle. So you're like, oh crap, I can't use right triangle anything. Okay, well then we're going to use the law of sines. Now notice, we use the law of sines, remember, if we have two angles and a side that's opposite of one of the given angles. Is that true here? 28.7 degrees, 102.3 degrees, and 27.4. So I'm going to say that again because really knowing when you can use it is the key. So we have two angles and a side opposite of one of the angles, so we can use it. Everybody good? Okay, so here we go. Let's go for it. So we're going to use the law of sines. So first of all, we could find angle A really quickly, right? Angle A is 180 minus 28.7 minus 102.3. So angle A is 49 degrees. Check. We've taken care of that. I'm going to write that in. Okay, now what we know is that sine of angle C, so sine of the angle, so sine of 102.3 over the side across from it, which is C, correct? Equals, let's use this one since we know that side. Does everybody understand? Equals is going to equal the ratio of sine of this angle, 28.7, divided by the side across from it. So those ratios, that ratio is a true statement. Now it's just algebra to get C alone. We only have one unknown, correct? So we would multiply both sides by C, am I correct? Okay, and then we would multiply both sides by 27.4. So we would have, right, you see what I'm doing? Getting no fractions, multiplying by 27.4, multiply by 27.4, so I'm going to show my work. We have 27.4 sine of 102.3 equals, those divide out, C sine of 28.7. Now remember, your goal is to get C alone, so my next step would be divide both sides of the equation by sine of 28.7. So C is equal to, you said what? 55 point, and then look at our original. This original triangle only had one decimal, so let's do one decimal. So see, did everybody get that? Were you able to plug that in just like it is and get it? Make sure your calculator's in degree mode because these are degrees right here. Okay, let's set up another, we can't use Pythagorean theorem, it's not a right triangle. So let's set up another ratio here. Next thing, so let's set up a true statement for this. So let's do it the easier way. Let's put the A on top. So we don't have, so A's on top. Does that make sense? So A over sine of 49, right? Is everybody good? Equals, let's just use whatever side we want. Why not go with this side again? So equals 55, now let's go with this side. Change my mind. Here's why I chose to go with this one. Because this was around, this was given, you know what I mean? You could still be right, but I just feel safer going with them. Okay, so 27.4 divided by the sine of 28.7. Now it's just algebra to get A alone. So look at, because I set this up in the smartest way possible, there's only one step to get A alone. Good. Good. Multiply both sides by sine of 49. Now, of course, we know when we multiply this side by sine of 49, it's going to divide out. So we have A is equal to 27.4 divided by sine of 28.7 times by sine of 49. Type it in, go, quickly. A is equal to, you got 43 exactly? 21 then, right? Perfect. Good. Questions on that part? Okay. No questions? Pretty easy? 43.1. Okay, great. Okay, next example here. Okay, so this is one that could very likely be seen on an ACT because it is written as a word problem and then you have to be able to decipher what's going on here. So it says a pole tilts towards the sun at an 8-degree angle from the vertical. It says away from the angle. Away from the vertical, so we have this picture here. Here's my vertical, correct? Vertical's up and down. It's tilting away by 8 degrees. So now it's making it not 90 degrees anymore. Does everybody see how now we're not dealing with a 90-degree triangle? It casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So let's put our X here. Now you would say to yourself, this is a non-right triangle, so I've got to solve this using non-right triangle information. So we're going to use the law of sines. Now look, we're given an angle and an angle. Okay, now I'm going to redraw this triangle here. So let's redraw this triangle. What is that angle right there?
98 degrees.
Good, 98 degrees. 90 plus 8, 98 degrees. And then this one's 43 degrees, and then this side's 22, and we're trying to find x. So we have two angles and a side. Now notice, the side isn't across from the angles, but that's okay, because I can get the angle aside. Nope.
39 degrees.
Oh, it is like the boat one, but we hadn't learned that yet. Okay, so this is 39 degrees. Okay, so now do you see how we can use our law of sines? So we're solving for a side, so let's put the side on top. So you'd say x over the sine of 43, right?
Yeah.
Equals, let's use this one, this side, so equals 22 over sine of 39. And now it's just algebra to get x alone. So it's pretty straightforward. Good. Multiply both sides by sine of 43. So we're going to have 22 over the sine of 39 times sine of 43.
43.
So x is equal to 23.8 feet. Questions on that? Pretty good, right? Okay. Not bad at all. So it says find the missing angles, sides, and angles. This is different. So you're going to want to watch. Don't say, oh, well, I already get it. So it's different. So notice we're given one angle and two sides. And notice that from that angle, one of the sides is across from it. Correct, everybody? 12, 22, 42. So we can use, let's put, this is side C. This is angle B, angle C. So let's go ahead and find an angle. We've got to find the angles first. We would have to find angle B first. Perfect. So why did I say that? Because that's the side across from it we have. Does that make sense of why I said that? Right, so let's set up our true statement. We know that the law sign says sine of the angle, so sine of B, so sine of angle B over the side across from it will be equal to sine of 42 over the side across. So now you're saying to yourself, I only have one variable, let's solve for that variable. So we're going to use algebra, so our first step would be multiply both sides by 12. Multiply by 12. So I rewrite it. Sine of B equals 12 sine of 42 over 22, correct? Now this is an angle. It's trapped inside a sine. What do we have to do to undo sine? Good. So we're going to take the sine inverse of both sides of the equation. So we have B, which is angle B, is equal to the sine inverse of all that stuff. So see if you can type it in correctly. You got what?
21.4.
Good. Angle B is 21.4 degrees. Okay, now let's find angle C the easiest way possible. So we would do 180. So angle C. 180 minus 42 minus 21.4. So angle C is 116.6 degrees. Now we could use the law of sines to find side C. So I would say side C, let's put it on top. So C over, so I'm going to find, so C over sine of the angle, which is 116.6, right? Will be equal to, let's just use, either one will work. I'll just go with this one. So equals 22 over the sine of 42. Now solving for C, we're going to have 22 sine of 116.6, right? I multiply both sides by Sinus 116.6 divided by sine of 42. So it's just algebra. It's just being able to set up a true statement and then using algebra correctly to solve for the variable. So can anyone calculate that? Did a few others get that? Okay, perfect. Inches. So not two shabs, right? 29.4. 29.4 inches, apparently. Okay. You don't understand what I'm saying right now? Okay. So we're going to talk about, it's called the ambiguous case for the law of science. So you guys remember hearing this last year, or did you guys not get into this last year? Okay. Yes, some triangles it doesn't work. So now we're going to be expected to be able to determine it. And it's going to make complete, total sense once I go through this with you. Okay, so some triangles in our picture can be deceiving. Sometimes, so the real question is, can you even make a triangle with the given information? So when we're dealing with given two sides and one angle opposite of the two sides, you can run into sometimes where you either have, there's a couple of different answers here, okay? So we're going to go through the different answers. I'm going to make sense of why they make sense. So there's a couple different things that can happen when you're given an angle and two sides, where one of the sides is across from the given angle. A couple different things can happen here. So here is a picture here. So I have, for example, this is angle A, let's call it, okay? So I drew this line. You might want to draw this. It's kind of nice to have the pictures to help it make sense. That's what we're about to get to. So we have this line here. I have angle A. So if this is 85 degrees, I am going to draw in 85 degrees. So think about it. Can I move that, or is that going to change the degrees? It's going to change the degrees. So I literally cannot move that. Right? Correct, everybody. Like I can't bring and move this down to connect it, because that would change the angle. Does everybody understand that? Okay. So now think about it. If this is angle A, this is side A, correct? I'm going to call this side B for fun. Now, so if we have this is 25 and this is 15, do you see how if this is 15 in length and this is 25 in length, there's a possibility that because I cannot grab and move this down, that this is never going to be able to come down and actually cross to make a triangle. Look, if I took this and swung this around, do you see how it's never touching? We can't move this, so that would be no triangle exists. Now I'm going to explain why, okay? Now I'm going to explain why and how you would know. Okay, so here is case one. So everybody, draw this picture in really quick over here. This is going to be really helpful. So if we have an angle A, we're going to say we're given the angle A, for example. We have this side, and then we're going to go up side B, and then obviously this is going to drop off and be side A, because angle A is across from side A. Well, think about it like this. So if we go up side B, and then we drop off, isn't this going to be the total height here? The altitude, right? The height. I'm just going to call it H, because I don't want to have to use A again. Okay, so this is my height here from this distance from down here to up here, correct? So think about it. A has to at least be long enough that it can cross, correct, everybody? Like we just talked about. So think about it, guys. If A is smaller than B, so if A is shorter than this length, and it's shorter than the height, isn't that going to be when this comes and can't cross? If it's smaller than this distance, is it ever going to be able to swing down and cross? No. Does everybody see that? Yes.
Why isn't it why would it if it's not
So first of all, the only time we're even looking is if A is shorter than B. So right now I'm saying if A is shorter than B, then that would be if we went to like this and measured it over, it's shorter than B. Does that part make sense? This is the first case. So I'm saying if A is shorter, oh my God.
But you're saying why like
We're going to have all the different cases come up here in just a second. So I'm going to try finishing explaining why this one particular case. Okay, so this is this is one case particularly. There's many more cases. So maybe I'll answer your question in one of the other cases. So if A is less than B, then look, starting here, and this is A. If I go over here, won't that be where A crosses, guys? Look. Now, think about it. If it's shorter than the height as well, it's never going to be able to come down and cross to make the triangle. Does everybody understand? So if A is less than B, and it's also less than 8, then it's going to sit here and swing around and not be able to come down and touch and make a circle. So that's what I was meaning to draw down here. So it's like this. It's going to sit and go like this and never be able to make a triangle. So that would be no such triangle exists. Everybody understand? That's just case 1. I just drew it in. Yeah, my bad. Does everybody understand why that makes sense though? Picturing it, swinging around. Never going to cross. And then you go like this, and cross H, and then cross B, and it's shorter than both, so it's never going to be able to hit the bottom.
Why would someone not draw it?
They're going to give you information, and then you have to determine if you can even draw a triangle with that. Okay, case 2 is if A equals the same, if A in length is the same as the height. Think about that happening. So I drew this in every time, so now I'm going to draw this out. So if this is our height, let's draw A the same height, guys, roughly. I'm going to try my best. So do you see how I'm drawing now this? I'm just extending it out, and we're saying that this height equals that height. Does everybody see? So maybe draw that picture, because it helps really make sense. So now I'm drawing it out. A is not shorter than H. It is shorter than B, though. It's shorter than B. But it is the same length as H. Now think about that. From here to here is the same length as from here to here. So now can't I take, and when I swing this side down, boom, won't it just make a right triangle? So that, if A is the same as the height, we're just dealing with one right triangle. And we can just use right triangle trick. So if A equals the height, that's going to swing down and touch right there where it was our 90-degree angle. So we would have just a 90-degree right triangle. If A equals the height. Does everybody understand that? Okay. Let's go on to case 3. If A is longer than B, then it's obviously longer than the height. Correct, everybody? Yeah. So we don't even need to put that. It's given. If it's longer than B, it's going to be longer than the height. So let's draw a true picture here. Let's say A is longer than B. Like here's B. Let's draw a picture here. Pretty long here. So there's A. It's longer than B. Then it's going to be able to come down, because we can move this angle, correct? We can move this one. We just can't move this angle, right? We're given this angle A. You can't move that, but that's just going to come down and cross in the right spot. So it's going to make one obtuse, non-right triangle. So what happens is, if you think about me drawing around, what's going to happen is, if I keep drawing this circle, so it's going to cross in the right spot, so I drew this out kind of wrong, isn't it going to cross more out here by how long I drew mine in? Picture me swinging this around. You know what I mean? So it's going to create one triangle, and what happens is, when I keep pulling this, so picture me grabbing that and pulling it, do you see how it overlaps and crosses around? Crosses in that one spot, goes around, and never crosses again? Does everybody see like what I'm saying? Picture me going like this and swinging a circle. It's not going to cross again, correct? Do you get what I'm saying? If I had a pencil, a string, boom here, and a pencil here, and I drew in a circle, it crosses right there, right? And as I go around, it's not going to cross again. So it creates that one triangle. Yeah, so it would have crossed more out here. By how long I drew it. That's just like that's one triangle that it's going to create. If A is longer than B. One exact triangle. Yes?
So like, you're like, the one you drew,
we're about to get to the next case. Okay, we're about to get to the next case. What part doesn't make sense so I can explain it better? Are you sure? Because I can explain that one more time. Is there anybody else confused with that?
Yeah, really good.
Okay, so if A is longer than B, so like here's Here's B, right? This distance.
Yeah.
Let's now go up over here and draw A longer than B.
What's that?
This is going to be the other side, right? It's going to create, does that make sense? This is side A. This is going to be side C. Right, but I'm now extending it. I had a triangle started. A, we need to draw longer than B. Does that make sense? So I'm going to draw it to scale. So can you just ignore that line for a minute? I'm going to go off to the side and draw in an A. This is side A, let's say. It's longer than B. Do you see how if I go around and draw a circle, it's going to cross right there? So that's going to create this one obtuse triangle. Yep, because if I kept drawing that in with my arc, it's going to swing around and not touch again. What? Yep. Or through the A, but that never crosses to make another triangle again, right? So then if I keep going, won't it just touch in that same spot, making the one triangle? Everybody understands? Yeah, if it was the same length as B, what's going to happen is it's going to cross. Okay, good point. So this is what happens. If it's the exact same length as B, like let's draw this, the exact same length as this, okay? Then what's going to happen? It's going to come down, it's going to cross, and it's going to cross perfectly there. So it still only makes one obtuse triangle. Nope, not ice. Oh, yeah, that would be isosceles. Because isn't A equal to B? True. Does everybody see what's happening here? Okay, good questions. Really good questions. Okay, the last case, yes? No, case, you can. We can, for all of these, the only one that we couldn't make it, so this one, we could use the law of sines or right triangle trick, correct? Case is just what could happen. So back here on this one, this is the only time we can't solve it because it doesn't even make a triangle. So what this is just explaining is how many solutions we're going to get. So this one would be no solution, correct? Because there's no such triangle. This one is one solution. This one's one solution. Does everybody understand? I didn't explain that very good. Okay, this next is the last case and the most interesting one. Okay, so is the bell going to ring? Because I don't want to start explaining it in the middle of that. Oh, we have 6 minutes. Perfect, that's plenty. Okay, so last case is this is just what could possibly happen. So if A is greater than the height, so greater than this, if A is longer than the height, but it's still smaller in length than B. It's still not the same length as B. So if it's larger than the height, so longer than this, but still less than B. Okay, so let's draw in something that kind of looks like that. So if it's longer than H, a little bit longer, correct? Yes, so you're going to see what's happening. So I'm just drawing in this side, but it's smaller than B. So this is B, A's got to be a teeny bit shorter, okay? So I'm going to erase a little bit, but we've got to know this is longer than A. So I'm going to draw in that. That's length A, let's say. That's longer than the height, look. Do you see that? But it's shorter than B. Like, look, if I draw B over, that would be right here, right?
Yeah.
You see how I'm doing that?
Yeah.
Okay. So now let's swing a circle around and see how many times it's going to hit. So isn't it going to come down, hit there?
Yeah.
It's shorter than B. Isn't it going to hit again?
No.
Yeah.
So it hits twice, right there and right there. So that's making 2 triangles. So the first triangle, when it swung down and hit here, is going to look like this. This was A. This is angle C, right? Angle B. This is side B, side A, side C. Do you see how that made that triangle if it hit there? Picture that putting it there. You guys see it? Now it's hitting again over here. So picture that line right here. Isn't that also making an obtuse looking triangle? Also, A, side C, sorry, side B and side C. Sorry, side B, angle B. Side C, angle, sorry, angle C, side C. So do you see how that makes 2 triangles? So we got to consider both of those. There's going to be two answers for that one. Yes.
So like if I was starting and doing like
So yeah, and once again, if it was the same length as B, it'll cross just perfectly there, so that would only make one triangle.
no, I'm
Oh.
like it was like
Uh-huh.
it goes like it's the bottom but wouldn't that just make it like
So that's a triangle, right?
yeah.
Well, that's non-right, and then this would also be where it hits another triangle.
Yeah.
Okay.
Like that I'm saying like it wouldn't hit, like it would hit right there too. Like that's not a solution, right? It's just a line and then
Oh, I see what you're saying. It's crossing, but we're making a triangle, so that would just be like a nothing, right? Does that make
Yeah.
sense? It's like how many triangles does it make?
okay.
Good question. Yes.
If you have that, then you know what triangle you
You have to solve both. There's both triangles there. Okay. So now let's put it into problems, and then it will make more sense, everybody, okay? It's all going to make more sense once we do some examples. So let's do this one. It says, does the triangle exist? So let's draw this picture out. You'll want to. I promise that it's going to click more. Just if you like, if it didn't click that time, watch, and then something might click this time. So we've got to go kind of quick here. We only have 3 minutes. I don't really have to start that much. Focusing. So here we go. It says, does the triangle exist? So let's draw in our line. Go up. Okay. Well, we delete. Delete. Okay, here we go. So we have an angle. I'm going to create angle A, and it's 20. So there's angle A. So this is 20.5 degrees. Everybody following me? Okay, now side A is 12 and side B is 31. So this is 31. We've got to draw this quite a bit shorter, correct? To make it drawn as much to scale as possible. Side A is about 12. Now we better figure out what this height is, because maybe if it's larger than the height, it's going to cross twice, correct, everybody? So let's figure out what the height is real quick before we continue the problem. So we would say, well, this is a right triangle. So sine, because it's opposite hypotenuse, so sine of 20.5 equals h over 31. So h is 31 sine of 20.5. So what is my height? 10.9. Okay. So this isn't really drawn to scale that good, but that's 10.9. So now this is longer than that height. So we've got to extend this 12 over. Longer than 10.9. Does everybody see how I've drawn it a little bit to scale? So now we're going to swing, because we've got to touch down. This isn't a triangle, so let's take that 12 and touch it down. Touches there, and it touches there. Correct. So we're going to have 2 triangles. So you got to go off to the side and draw a true triangle. So let's draw this in. This was the 20.5. This is side 31. This is 12. And then we also had it touch here, correct? Guys? So we also have this. So this is 31, 12, and 20.5. So now we're going to solve this using the law of sine. Let's focus on the top one. We have 2 triangles to solve here. So we're going to say, we've got to use the law of sine. So we would say sine of 20, now let's find this angle. This is angle B, or let's just, this angle, yeah, angle B. Okay, B. Okay, so sine of, let's start with the unknown. So sine of B over the side, which is 31, will be equal to sine of 20.5 over 12. Solve for angle B. So we would multiply both sides by 31. Now it's just algebra, so never get thrown off. And here we've done the hardest part. So we have sine of B equals 31 sine of 20.5 divided by 12. And now don't let this throw you off, because you said, this is kind of the confusing part. But once again, it's just algebra. B is trapped inside sine. So to undo sine, you would take the sine inverse of both sides of the equation. No, yeah, I knew you understand it, but I'm just saying, explaining again, like, don't let it throw you off at all, because it's just algebra. So we have the sine inverse of 31 sine of 20.5 over 12. So type that in to your calculator, and we get angle B is what? 61.1 degrees. Now, isn't that an acute angle? Acute means smaller than 90. Okay, so this right here is this angle, 61.1, because doesn't that make sense for that angle, but not that obtuse angle? Okay, well, think about what sine is. Now think about what sine inverse gives us. Sine inverse, remember back to sine inverse. Aren't all of our answers only between negative pi halves and pi halves?
Yeah.
Okay, so that's why we're not getting the obtuse answer here. You can't get it. You've got to think about it on your own. What? No, that's just why it's only giving us the one answer. Because it gives us, the only answer it gives us is the one on that interval, between negative pi halves and pi halves. Isn't that on that interval? Think about where 60 degrees is. 61.1. So we've got to do it by ourselves, because there is another triangle. This has an obtuse angle. So think about it, guys, x, y. So if I go over here and draw in 61, right here, that's 60, up this way, we have 61.1 degrees. Well, that's an XY point. Now remember, sine is Y, correct? So over here, in this quadrant, we have an X and we have negative XY. Isn't the sine the same value, guys, for this? So from here up to here was 61.1. So that other triangle is coming there. That's where that obtuse triangle came from. Does everybody see it? Because that's the acute one. That's the acute angle one. So we also have an obtuse one. So how would we find that? When you do 180 minus, we could do this 180 minus that, right? To give us the obtuse, to give us that angle, right? The obtuse angle. 180 minus that 61.1 would give us that big obtuse angle, right, everybody? So do that in your calculator. 180 minus minus 61.1. Okay, perfect. So this angle B is 118.9. So we have these two triangles we've got to solve now. Okay, let's finish. Well, we could finish solving if we need, but I think this one, it says those triangles solely have a finely missing side. So now we would just continue the law of sines, continue the law of sines on both. Do you want me to keep going? Yes.
Basically, it's like showing a little bit of the triangle, but it's really
Okay, so this triangle right here has the same sine value as this triangle, correct? Sine is y.
Yeah.
So this is the so we said what is, so when we found the, sorry. So if I said what's the angle, our output is our answer here, but there's two there's technically this answer as well. So what degree is that? Gonna have the same answer in. I didn't explain that right.
Can you redraw it?
Redraw which?
Yeah.
Yes. Okay, yeah, absolutely. Okay, let's start over with that part then. If that's the part that's confusing you. Okay, let's try in 61.1 degrees, correct? Okay, so we go up this amount from here to here, and that's an XY point, right? That 61 degrees is going to have an XY, 61.1 degrees is going to have an XY point, right? If I said to you, find the sine of 61.1, it would be this Y value, correct? But also, what has the same output as that Y? Which angle? So that's a triangle, right? We could draw that down.
So that's the one thing. Like that's the third one.
Well, this isn't a right. Well, this wasn't a right triangle. So like, how do I explain this? I got 64.8. Speak up then, guys. 64.8. Okay. So now, how do I explain this better? Here's why. What does this mean? Okay, so let me explain again. What does sine inverse mean? It says what angle has this answer, correct? Sine inverse means what angle has this value. Where does my find this value? Well, that value is going to happen in two places because sine is output, y value, correct? We're not doing, so sine is y. So then over here at this point, it's negative x, positive y. Right? So the y value and the y value here are both sine. Right. So then this angle, this from here, we just clear this up this way, right? This is 54.8. So then this angle from here to here, you could figure out by doing 180 minus 64.8. And that obtuse angle has the same answer, as same sine value as that, doesn't it? If I said, what's the sine of that, you would say that. Isn't that the same answer as saying what's the sine value of this obtuse angle? So you have to have both.
So why is it like the other one? Why is that one? The connection between the 64.8 and like the graph, why does that make it the other one?
So here's another way of thinking of it. I guess here's what the thing is. We don't know this side. Let's see if this helps. We don't know this side, right? Let's say we didn't know, for example, angle B at all. We know for a fact that angle B has got to be larger than this angle, correct? This is another way of thinking of it. So angle B is at 30 across from a 31. So it's definitely larger than angle A, correct, everybody? Because doesn't A have a smaller side? Angles correspond to the side. Now, do we know if this is the smaller angle? Because one of them is going to be smaller than the other, right? Is that the small angle or the obtuse angle? We don't know because we don't have enough information here. So we do both. Obtuse. Right. So we're saying there's two cases. What if it's the acute angle? Here's our triangle. But what if it was the obtuse angle? Here's our triangle. Does that help a little? Okay, sorry. This is different. Okay, let's do number 6 out of the book. Okay, here we go. So it says, given this, does the triangle exist? If so, let's figure it out. So in your book, so let's draw this in again. Here we go. So angle A is 60 degrees. Side A is 9. This side's 10. We better figure out the height. So we would say sine of 60 equals h over 10. So h is equal to 10 sine of 60, right? I'm figuring out my height to know if it does exist or not. And if there's two triangles, then I need to solve both. Or find whatever it is. So it's 10 sine of 60 I got when I did it in my calculator was 8.6. So this height is 8.6. So we're dealing with, I typed that into my calculator. So right here is a right triangle, right? Opposite and hypotenuse gives me sine, so I can figure out my height. Does that make sense, everybody? So now, once again, it is longer than that height. So once again, we're dealing with that issue of it's crossing here, correct? And then crossing here. Height, it is 8.6, but isn't this longer than 8.6? Oh, so it's going to cross and cross again, right, everybody? Yes. So now so do you see how right now, do you see what I'm saying? Like, we don't know if it's the acute angle or the obtuse, you know what I mean? There's an acute and an obtuse. So we have, let's draw that in. So we have that triangle that looks like this more, with our 10, our 9, our 60, and that's all we've got. Then it also crossed right there. So that's when B was obtuse, right? Yeah. Once again. So now we have this other triangle here that looks more like that with an obtuse. So we have this is 60, this is 10, this is 9. So now we could go through and solve. So we would say, we could figure out that angle. So we would say, law of sine. So we'd say sine of star over 10 equals sine of 60 over 9. And then we would solve for star. Star equals, can we do it in our heads? What the algebra is going to come out to be at this point? Or inverse sine, sine inverse of when we multiply up and then take the sine inverse, everybody. So we would have 10 sine of 60 divided by 9. So what is star? It's what? 74.2. Did everybody else get that so that we are good? 74.2. Now that was the acute one, so that's why I'm putting it in here. Does that make sense? 180 minus that would be the obtuse one. Yes. So take 180. We talked about why. It's a reference angle. Remember back to reference angles. So because once again, sine inverse only gives us the answers, outputs between negative pi halves and pi halves, you know, but we don't know for sure if that's the acute angle or obtuse angle. Does that make sense? So now we also have this. So take 180 minus that, and we get what? 125.8? 180 minus 74 point whatever. We're just trying to find this angle right now. 105 point. Okay, cool. And now we could go through and finish with the law of sine for all of these. Does that make sense? Do I need to keep going? You're sure? Okay. 74.2, but if you pay attention when I'm saying it instead of talking, then you would have heard me say it. 74.2, I think, is what we ended up getting, right, everybody? Okay. So then we would continue, depending on what it's asking us, solving the triangles, or if that was, I don't know, I think it said solve it, so we would keep going. So now we would be able to find out those other angles really easily, correct? And we would set up the law of sine to figure out the rest of the sides. Okay. All right, so does this triangle exist? So once again, we would draw our line, go up 30 degrees, cool. So this is A, side A is 5. Side B is 10. Let's figure out our height. So you would say, because this is a right triangle, opposite and hypotenuse. So that's sine of 30 equals opposite over hypotenuse. So 10 sine of 30 equals h, height. So what do we get? I can't. 5. So now this is actually the same length as that, right? So it's a right triangle. So we found that other side. It is 5. And then we could go through and just do right triangle trig for the rest. Or we could use law of sines if we really wanted, but we probably don't want it. Okay. Okay, so this is the last thing. So that's, you got it then. You guys understand it. So that's when you just got to check to make sure you can make, if you're making one triangle, no triangle, or, you know what I mean? Two, like, did I say 2, none, or 1? All right, so now we're going to talk about area of an oblique triangle. So to find the area of a right triangle, you use 1/2 times base times height, right? Of a right triangle. These are non-right triangles. So this is the formula. Area is equal to 1/2 times side B times side C times sine of A. But I don't like to say that because people get caught up in the B's, C's, and A's. Because really, to find the area of a non-right triangle, you just take 1/2 times side 1 times side 2 times by sine of the angle in between. So that's better to remember because really it could be any side, as long as the angle in between you're given. You can find the area. Now, if you're interested on how they got that, they go through and use 1/2 times base times height. They drop down a height, and they go through and show you how to do it. If you're really interested in looking at why that works, like why this formula works, that's great. Go to page 434, and you can kind of look through that. But we just don't have time in class to talk about why that works. that make sense?
Wait, which one is better?
They're both the same thing.
Which one is better?
Because it could be, you could be given, it doesn't have to be B and C given inside B and C. Like, you know what I mean?
Just means side 1 and side 2.
Side 1, side 2 times by sine of the angle has to be between them. So look, here's, because of this formula, if we were given angle A and side B and side C, we could find the area. Side 1, side 2 times by sine of the angle in between. Right. Yep, if you were given these two, you would have to use that angle to find the area. And so forth. That's why I don't like to memorize that. I just say 1/2 times side 1 times side 2 times by sine of the angle in between. Okay, here we go. So it says find the area. So you say, can I find the area of this triangle?
Yes, you can.
That side, the angle in between. We're all good. So area is equal to 1/2 times side 1, which is 52, times side 2, which is 90, times by sine of the angle in between. That's all you got to do. Type it into your calculator, and we would get whatever we get. So you guys tell me. You can really just type it in.
Yeah. Wait, 1,288.86
Yeah. Okay, cool. So look at this one, the last example. This is literally the last example, then you can start on the homework. So it says find the area. So you side 1, side 2, we need the angle in between. Uh-oh. Problem. Okay, so first of all, yikes. We don't have that angle. Should we figure it out? Yeah. Okay, so we're going to have to figure this out using law of sine. So we're going to have to figure out that angle first. Why? Because we know that side, correct? So we're going to say sine of star over the side across will be equal to sine of 25 over 10. Let's solve for star. So we would have sine of star equals 3 sine of 25 over 10. Now solve for star. Sine inverse, right? Star equals sine inverse of all that stuff. 3 sine of 25 over 10. So once we know star, somebody calculate it. 7.2. Okay, cool. Now so that we can find the area, let's hurry and figure out that. So 180 minus that minus that. Oh. $127.1. Okay. 147.7. So now can't we say area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between. Does everybody understand how to do that? So I had to do a few extra steps to figure out enough information to actually find the area. So you would just type it in. All right, the time is yours. You're welcome. Yeah, it is. 8 point, I got it already. I can't find my work. 8.01, there it is.
Hey, what was the last number? 6.8?
Yeah, that is due today.